Everyone, thanks for coming. And today we are going to do a review of the lectures in week 6. So in week 6, we mainly learn how to prove things. So first, we can prove by counterexamples. This is based on the logic that A implies B is equivalent to not B implies not A. So they are logically equivalent. Therefore, if we need to prove if A then B, we can instead prove if not B then not A. If we can prove if not B then not A, then A implies B also holds true. We can also prove by contradiction. Suppose we are going to prove if A then B. Therefore, we can assume the conditions in A supposed to the contrary not B is true. Then we argue until we reach contradiction, which means that we argue if A then not B is a contradiction. Therefore, since B is always true whenever A is true, we have proved if A then B. So how do we get contradiction? If we are dealing with a proposition with natural numbers, we can use the well-ordering principle. So the well-ordering principle states that every non-empty subset of natural numbers contains at least element. For instance, for the statement every natural non-integer is either odd or even, how do we prove that? We prove by contradiction. We assume that there is a least integer, natural integer that is neither odd nor even. We can get a contradiction actually because x minus 1 is an even smaller integer until x equals to 0. But x equals to 0 is a even number, so we can arrive at a contradiction. So the well-ordering principle can help us prove propositions when we are dealing with natural numbers. Namely, we use the least number element in the proof. So, to be more specific, how can we prove by smallest counterexample? Suppose we are going to prove if A then B. We start by assuming that A is true. We show that if A is true, B must also be true. Assume there exists a counterexample where A is true but B is false. Therefore, after that, we use the well-ordering principle to establish the existence of a smallest counterexample. Then we can argue that the smallest counterexample cannot exist. It's a contradiction, which will lead to a conclusion that A implies B. That's all what we have learned in this week. Basically, we are dealing with different proving techniques, how we use the smallest counterexample theorem to prove things. Thank you.